7.2 today. We're going to do special right triangles, part 1. We're going to do 30, 60, 90 triangles today. They're special. There's a very special relationship. Special just like these two guys. And actually, these two guys are going to use 30, 60, 90 triangles later on, and I'll show you how. Alrighty, so let's take a look at this. We already know how to do this stuff. Let's find the missing side. We're going to use Pythagorean theorem. Alright, so I'll call this x. So this is a squared plus b squared, so 5 squared plus x squared equals c squared, 10 squared. We know that's 25 plus x squared equals 100. I'm going to subtract 25 and I get 75. I'm going to take the square root of that. Now, we usually, when we have this, it's plus or minus, but since it's a distance, it's only positive. So that's going to be 25 times 3 is 75. The square root of 25 is 5, radical 3. So we have sides of 5 radical 3, 5, and 10. All right, let's come over here. Same thing, we'll call this side y. So we have y squared plus 4 squared equals 8 squared. All right, so that's y squared plus 16 equals 64. Subtract 16. All right, so y squared equals 48. Take the square root of that. Again, only going to use the positive or principal root because we have a distance. So that's 16 times 3 is 48. So that's going to be 4 radical 3. All right, if you look at these, a couple of things you should notice. Well, maybe not, but if you actually spend some time, pause the video and look at this, see if you can come up with a relationship, you're going to see a couple of things. First of all, we have across from 30 is definitely the shortest side. All right. The middle angle, 60, across from 60 is the medium side, 4 radical 3. And then across from 90, the biggest angle is the biggest side, 8. Which makes sense. The shortest side is across from the shortest angle. The biggest side is across from the biggest angle, and the medium side is across from the medium angle. Notice that the short side and the big side, 4 to 8, well, that's double. 5 to 10, that's double. That's a good relationship. Notice the other thing. 5 radical 3. Short side radical 3. So these are a special relationship that will always work. And the nice thing is this. For a Pythagorean theorem, we have to have 2 of the 3 sides. If we have a 30, 60, 90 triangle, it will always work and it'll always be in this relationship. Across from 30 is that short side, and we'll call it 1. Across from 60 is always going to be radical 3. And across from 90 is 2. It's always going to be in that ratio of 1 radical 3, 2. Sometimes you see ratios written like this. All right? You'll always have that. If you know this side, you know double it will always be the long side. If you know this side, you know if you multiply by radical 3, you'll always have that. All right? So, now we don't have to, we can have only one side and find these things out, which is very nice. Let's do this. We can use similar triangles. There's a couple ways to solve this. I'm going to show you 2 great ways. The first way is similar triangles. So I'm going to draw a similar triangle right here, or as close as I can. And I'm going to label it with my my ratio. So across from 60 is going to be radical 3. So this is across from 60. Across from 90 is 2, and across from 30 is 1. So now I'm just going to solve a similar triangle like Mr. Bruss did in unit whatever, 6. So now I'm going to start with my unknown. So 4, I know 4, and it's the same as what? It's the same as 1. Let's see, I want to find m. I know m is the same as 2. And then it's just about solving it. Now, a lot of you are just going to say cross multiply. And yes, you're right, cross multiply. But I like to simplify. 4 divided by 1 is 4, and then multiply by 2, and we get 8. All right? Now, I know a lot of you are saying, can't you just double that? And yes, of course, that's a shortcut that you're going to see in a little bit. But I want to, of course, do everything the hard way first. You know how I am. All right, let's do the next one. I always start with the original relationship because let's say I get this wrong, and you know how some of you are. You do 4 times 2, you get 6. You want to get at least one of these right, so I'm going to start. I know 4 is the same as 1, and I know k is the same as radical 3. All right? So 4 divided by 1 is 4, and then k divided by radical 3. I know the opposite of divide by radical 3 is multiply by radical 3, and so I'm going to multiply by radical 3 over here, and that's just 4 radical 3. Now some of you are going to have troubles with radicals this unit. Unit 11 in algebra will help you that, but remember, when you're multiplying or dividing radicals, you multiply the outside with the outside. So 4, I would have multiplied it. If there was an outside part here, I would have multiplied it. If there was an inside part over here, I would have multiplied it. There's not. We'll get to some that have that, all right? But you can only multiply outside with outside and inside with inside. Now I'm talking about outside the radical or inside the radical. All right, so let's try another one here. So again, I'm going to draw my reference triangle. That's what they're called, reference triangles. All right, across from 60 is radical 3. Across from 30 is 1, and across from 90 is 2. So here we go. I know 18 is the same as 2, because across from 90 is across from 90. And let's see, I know G across from 60 is the same as radical 3. So 18 divided by 2 is 9. Multiply by radical 3, and I have 9 radical 3. It's not 9 times 3 because radical 3, the 3 is on the inside of the radical and the 9 is on the outside. All right? So now we have G. All right, let's do F. I know that 18 is the same as 2, and I know that F is the same as 1. So, again, this one, I don't really need to cross multiply because F divided by 1 is just F. 18 divided by 2 is 9, and we are done with that one. All right, let's take a look over here at this one. I'm going to draw my reference triangle right here. Whoa, that's not really good. So this is 60, so across from 60 is radical 3. Across from 30 is 1, and across from 90 is 2. So let's see, what do we know? We know 9. So 9 is the same as radical 3. Notice I always draw my reference triangle the exact same orientation because it's just easy, same spot, all right? Let's see, I know B is the same as 1. Well, B divided by 1 is just B. That's easy. Now we have 9 divided by radical 3. All right, 9 divided by radical 3. We have to remember that when you have a radical in the denominator of a fraction, you must rationalize it. And if you're not sure after you see me do this again, you're going to want to go to 11.2. All right, I would hate to fail geometry because I forgot my algebra. So, rationalizing, I take the radical in the denominator and I multiply top and bottom by that radical. So 9 radical 3 is just 9 radical 3. Why did we do this? Because 3 times 3, they're both inside, so that's now radical 9. And so now that is 9 radical 3, and the square root of 9 is 3. And see right there, we got rid of the square root. All right? As you get good at this, you could have gone right from the square root of 3 times the square root of 3 equals 3. And then I want to simplify 9 divided by 3 is 3. So it's 3 radical 3. All right? So that's B. Let's do A. I know that 9 is the same as radical 3 as A is to 2. So I'm going to multiply that up. I have 18 over radical 3 equals my A. I'm going to rationalize this. And like I said, when you get good, well, I'm good. Radical 3 times radical 3 I know is 3. So 18 radical 3 over 3 equals A. 18 divided by 3 is 6. 6 radical 3 equals A. All right? There's that one and the last one. This is a lot of work, isn't it? Hopefully you understand this and see why all the work's important. I think it's going to help you in a second when I show you a trick. So, across from 60 is radical 3, across from 30 is 1, and across from 90 is 2. Here we go. 2 radical 3 is the same as radical 3, as m is to 2. All right? So now look at this. I have the same number on top and bottom. Anytime you divide, any number divided by itself is 1. So those essentially cancel out. So now we have 2 equals m over 2, and multiply by 2, and m is 4. There we have it. Boom. All right, let's find n. So 2 radical 3 is the same as radical 3 because they're both across from 60, as n is to 1. Divide that out, we get n. Radical 3 of radical 3 is 2. Okay? So this is solving using similar triangles. If you don't like that, maybe you'll like what is next. Alright, so let's take a look here. We have a shortcut. Now, if you don't like the shortcut, you can use the long way. It's always going to work, but this is a shortcut. Lots of you always ask me for shortcuts. So, shortcut, always start with the side, the short side, or get that side first. So I'm looking at using the 1 because 1 is a very nice number to work with. We're going to multiply when we go to a bigger side. So, for example, if I start with 1 and I have 1, when I go this way to the big side, I'm always going to multiply by 2. All right? If I'm going from the short side and I'm going to the middle side, I'm always going to multiply that number by radical 3. Okay? When I'm going back to the short side, so I'm starting at a bigger side and I'm going back this way, I'm going to divide. All right? So if I start at 2 and I want to go to 1, I'm going to divide by 2. If I start at radical 3 and I go to 1, I'm going to divide by radical 3. Let's take a look at here. So I have the middle side. I said always start by getting the short side first. So here's the short side. To go from a bigger side to a smaller side, I divide. So I'm going to divide by what is across from 60. Across from 60 is always radical 3. So I'm going to divide by radical 3. So 3 radical 3 divided by radical 3, these cancel, and I have y is 3. Now I have this, I'm going to go to my bigger side. When I go to a bigger side, I multiply. So I'm going to multiply by the ratio, which is 2. 3 times 2 is 6. A lot less work, and if you understand it, it's a lot quicker. All right? If you don't understand it, the shortcut won't work, so it won't be beneficial to you. But I hope you do understand it. I hope you use it because it is a nice shortcut. Let's look at this one. All right, I have across from 60. So I want to get to the short side first. To get to the short side, I am going to divide by radical 3. So 4 radical 15 divided by radical 3 is going to give me my short side. All right. And inside the radical, I can just divide. 15 divided by 3 is 5. So now that's 5. I have nothing on the outside, so it's like a 1. 4 divided by 1 is 4. So my short side is 4 radical 5. To go from my short side to my big side, I have to multiply. And this is the ratio of 2. Multiply by 2. So u equals 4 radical 5 times 2. There's no radical here, so it's going to be 5. It remains unchanged, but 4 times 2, they're both outside, so that is 8. So u equals 8 radical 5. All right? Let's try this one. I have the side across from the 90. I have the biggest side. I want to get the shortest side first. All right? To get to the shortest side, I'm going to divide. What am I dividing by? 2. So I divide by 2. No radical, so the radical 3 stays. 6 divided by 2 is 3. So y equals 3 radical 3. Now I'm here, I have to go to the middle side. It's bigger. When I go to a bigger side, I have to multiply. My ratio for my bigger side is radical 3. So 3 radical 3 times radical 3. They're inside, so that's going to be 3 and 3 is 9. The square root of 9 is 3, so I have 3 times 3, which is 9, so my x equals 9. All right, very nice. Like that shortcut a lot. All right, so now what we're going to do is we're going to take it up a notch. You can do it either way. We have a two-stepper. All right, we want to get to this, but if you notice, I don't know any side in this triangle. What I do know is the side in the other triangle. Right? So what I want to do is this. I want to find, first of all, what is that common side? This is the common side. It's shared. If I can find that, we'll call it y. Then I can get to my x. So I want to get to my x. So I have to find y first. So this is the short side because it's across from 30. So to get from the short side to the medium side, I have to multiply by radical 3. So my y is going to be 5 times radical 3, or 5 radical 3. All right? Now you can just ignore this triangle. If you need, just, draw a new triangle. So this is 5 radical 3. This is x. All right? Now, I'm going to get to the short side, even though I don't need it. That's my trick, all right? There's no great way to go from here to here. I'm going to go from here to here. So I'm going to divide by 2. So 5 radical 3 divided by 2. We'll call this side w. All right? Well, this is kind of nasty, isn't it? That's a fraction. So this is 5 radical 3 over 2. That's okay. We can use fractions. All this is, I'm going to rewrite this so it doesn't look so bad. This is 5 halves times radical 3, okay? Now I know that going from the short side to the medium side, I have to multiply that by radical 3. And here's why that's not so bad. That's not so bad because radical and radical is radical 9. The 5 halves I didn't have to mess with at all. So now I have 5 halves times the square root of 9 is 3. Now that might be a little bit tricky, but we know multiply the tops. That's 15 over, multiply the bottoms, 2. All right? All right, so Mr. Kelly called Mr. Brust over to his house to move a box up some stairs to his second floor, like he saw how to do on the Big Bang Theory using math. So let's watch that clip right now.
I guess we'll just bring it up ourselves.
I hardly think so.
Why not?
Well, we don't have a dolly or lifting belts or any measurable upper body strength.
We don't need strength. We're physicists. We are the intellectual descendants of Archimedes. Give me a fulcrum and a lever and I can move the earth. It's just a matter... I don't have this. I don't have this. I do not have this.
Archimedes would be so proud.
Do you have any ideas?
Yes, but they all involve a Green Lantern and a power ring.
Easy.
Easy.
Okay. Now we've got an inclined plane. The force required to lift is reduced by the sine of the angle of the stairs, call it 30 degrees, so about half.
Exactly half.
Exactly it. Let's push. Okay. See, it's moving. This is easy. It's all in the math.
What's your formula for the corner?
What?
Those guys in math are awesome. They make it just awesome. Whatever. It's funny. I love it. So when they were finished, they wanted to see how far they moved it. All right, so they measured along the floor and realized the longer leg was 12 feet long. Okay, so if you remember from the video, they talked about a 30-degree angle. All right, so it says going up 30 degrees. So the longer leg would be which of these two legs? Well, we know this is what we want to find. The longer leg would be right here, right? So that's going to be 12. All right, so if you want to use your shortcut, you got to go from here to here, and then from here to here. You can do that, or I can use similar triangles. I'm going to use similar triangle right here. Sometimes similar triangles are easier because this is radical 3 and this is 2. So x over 2 is the same as 12 over radical 3. So this is x equals 24 over radical 3 because multiply that up, right? Rationalize this. So that's 24 radical 3 over 3, which is 8 radical 3. So go measure off 8 radical 3 feet and we will be set. Oh wait, 8 radical 3 doesn't make a whole lot of sense, does it? So I would put that in my calculator because this is a real world situation. And I would find out that it's about 13.86 feet. So pause the video and try these on your own. So you can see I did this one with similar triangles. On the homework, I'm going to do half of them with similar triangles, the left column with similar triangles, the right column with the shortcut, just so you get a chance to see them done both ways. You can do them however you want, all right? Pick a method that's best for you. So over here, I have 3 radical 3 over the same side as 1, and y over the same side radical 3. Multiplied radical 3 up, got radical 9, which is, the square root of 9 is 3. 3 times 3 is 9. So y was 9. Then I did the second 3 radical 3 over 1, and then the big side over 2, which is 6 radical 3. Over here, let's do this one. We need to find the common side. This is the common side. All right, I'm going to use a shortcut. So I'm going to go from the small to across from 90 is the biggest side. So I have to go from small to big. I have to multiply by my ratio of 2. So this side right here is going to be 5 times 2, 10 radical 6. See, that radical looks nasty, but we didn't really even use it. So now I'm looking at just this big triangle, right? And what do I know about the big triangle? Well, this is the short side of the big triangle, and I want to go from the short side to the biggest side, so that's by multiplying by 2. So I take my short side, multiply it by 2, and I get 20 radical 6. And there you have it. All right. Best of luck on the master check, and I will see you on the flip side.